Recording in progress.
Assalamu alaikum warahmatullahi wabarakatuh. Now we are going to start with the variation in the ionic radii and the atomic radius across the periods and the groups. Okay. If you know the what is atomic radii? What is atomic radius when we talk about this? Can you hear me?
Atomic radius?
Sorry.
Can you hear me?
Yeah, I can hear you.
I don't know what atomic radius.
But your voice is too low. I mean, like, sound is volume is too less.
It's like the normal radius,
Yeah, it is just like
but
the
of the
and
atom.
we will discuss over here the atomic radius of the element and like because generally we don't talk about the atoms. Have you seen the atomic table? We have discussed the periodic table of the elements. We don't have any periodic table for atoms. Okay, why? Because atoms are too small. In general we talk about the at elemental level. So whenever you are going to discuss about the radius, you will discuss about the elements radius, and we can calculate the elements radius. We can determine the elements radius by the atomic radii. So the atomic radii of an element is the simply it is the measure of the size of an atom. Simply we can say it is the measure of the size of an atom, that how much is the size of that particular atom. And whenever you it is the measure of size of an atom for a particular element. Okay. And if you see this, what general idea comes in your mind? What is this?
Covalent, covalent, covalent radius?
Yeah, this is the way by which we determine the atomic radii. Like you have the atomic radii of hydrogen atom will be determined by the having the distance between the nuclei of two hydrogen atoms. Actually, these are two hydrogen atoms, and this is the center. Okay, this is the center of one hydrogen atom. This is the center of the another hydrogen atom, the second hydrogen atom. So you know that there will be a distance. The distance between two hydrogen atoms will be from here, from this point, this center, till this. Okay, till this you have what? You have the uh, distance. Okay, and by halving this distance by when you have half d by 2, so you can easily get the r. Okay, you can easily get the radius, the atomic radius. And I told you why we are calculating radius. We are calculating radius so that we can have general idea of, we can have general idea about what can be the size of that particular element. Okay, that is why we determine the atomic radius of different elements to get the general idea of the size of the atoms. Clear?
Yeah.
So it is the measure of size of an atom for a particular element, and why we are doing it so is to get the general idea. And how we calculated it, it is the it is half the distance. It is half the distance between two nuclei of two covalently bonded atoms of same type. Now my question is this: why there is covalent bonding?
What is covalent bonding?
Between these two atoms.
Um,
uh
because they're like sharing the electrons.
Because
They
they
share
are
electrons.
from the same. What is you have done the ionic bonding and covalent bonding in IGCSE, right? What is the difference between ionic bonding and covalent bonding?
Ionic bonding
Mm-hmm.
is when they like release or take
When you have
electrons.
yeah, when you have ions, simply you can say the ionic
Yeah,
bonding will be in between two ions, right? Covalent bonding happens when there is very less electronegativity difference between the elements, between the atoms of the element, and it occurs usually within the same type of atoms. Okay, when same type of atoms bond together, so most common bonding type is covalent bonding over there. Clear? Are you getting this?
yeah,
In the same type of atoms, when they bond together, there is covalent bonding. That is why we are saying this, that it is half the distance between two nuclei of two covalently bonded atoms. Okay, these two atoms are covalently bonded. There is covalent bonding in them, and these two atoms are of same type because these are hydrogen atoms. Okay, this overall this is a hydrogen molecule, and this is hydrogen atom. This is one hydrogen atom, this is second hydrogen atom, and they both are linked with covalent bonding. Clear?
yeah,
Okay, that is why we can also say this covalent radius. Okay, the atomic radius is also known as covalent radii. Clear?
yeah.
And how we get this, how we get the covalent radius? Why, you know why we need to have two bonded atoms to know about the radius of one atom? Why is this so? Why can't we have just this?
Because it's too small.
Yes, because it is too small, you cannot get the radius by just one atom. So to calculate the radius, to determine the radius, you need to check the molecule, and usually hydrogen molecule is present. You don't have hydrogen freely available. Hydrogen atom is not freely available. It is bonded with some other atom. So the hydrogen atom is bonded with hydrogen atom. When it is bonded with hydrogen atom, it will form hydrogen molecule. So usually it is present in the molecular form. Okay, in the form of hydrogen molecule. So from here we can determine the atomic radii. Clear?
Yeah,
Okay, now we will discuss the general trends of these. uh, what is the general trend in the periodic table? What is happening? When we talk about the atomic radii, we say that the atomic radius of elements decreases across the period. Okay, let me move this. Okay, it is not moving. What we are saying, that whenever you go from left to right in the periodic table, you will see that the atomic radius will decrease. Okay, the atomic radius will decrease, like this one. You see this, like the hydrogen, we will go from this lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine and neon. So you see across the period, what trend you are observing over here?
They get smaller.
That yes, the lithium is from the group 1. In from left to right, when you go in the periodic table across the period, the atomic radii decreases. Okay, and the when we talk about the reason why it decreases, what can be the reason for this? When we go from left to right in the period, the nuclear charge, we say the atomic number increases. Okay, when you go from left to right across the period, the atomic number increases. And what is meant by atomic number increase? What is meant by this statement?
The atomic mass increases.
Atomic number means the number of protons is increasing, right?
Yeah,
So when the number of proton increases, what will happen? Uh, when proton number increase, isn't it that electrons will also increase, because we have discussed that there are equal number of protons and electrons in a neutral atom, isn't it?
yeah,
So why we are saying that the atomic radius decreases across the period? If we are saying that atomic number is increases,
because
because those extra electrons will only add into the same shell. Okay, I am writing this statement and then I will explain you what I am saying. I am saying that across the period, the atomic number increases. Okay, but the extra electrons will be added up in same shell. Okay, that is why we are saying that across the period, the atomic radius decreases. You know why it will decrease? Because if you observe this, what is happening over here? Like for example, uh, let's say we can take the example of fluorine, right? Fluorine has the 9, its proton number is 9. Okay, its proton number is 9. It means in the nucleus, inside nucleus, there are 9 protons, right?
yeah,
But the electrons will be in the same shell, in the same revolving outside shell, the principal quantum shell. We will discuss the shells later on, but at this stage you must know that across the period, from left to right, atomic number increases, number of proton increases. When number of proton increases, what will happen? There will be more strength in the positive charges. the nucleus will have more strength to attract the electron towards itself. Are you getting my point? When proton number will increase, what will happen? Inside nucleus, the protons, since now protons are more, so they will attract electrons towards themselves. And when they will attract electron towards themselves, what will happen? The size will decrease.
Yeah.
So this is the reason that across the period we say that the atomic radii decreases. Okay, so across the period atomic number
Because
increases, and what will happen now?
the electron shells,
Sorry,
because the electron shells get closer.
I can't hear you
That's what you're
properly.
saying. Are you saying it's because the electron shells get closer?
Electrons will be in those shells. Yeah, they will be, their size will be reduced only. The electrons will not go anywhere. They will be in their shells, in their particular shell, in their particular same quantum principal quantum shell. Okay, they will not move anywhere. Just the size will be reduced. There will be more attraction towards nucleus. Okay,
Okay.
as the as atomic number increases, protons will attract electrons with more strength. Clear?
Yeah.
Okay. Now we are going to discuss discuss about the trend in the group. Trend in the group. Down the group. We say down the group. When we talk about the groups, what happens? What is the common property of group? How we have the periods and groups? How we have arranged this? On what basis? On which basis?
They have the same number of electrons in their outer
Yeah, in their valence shell. In
electron
their
shell.
valence shell. Yes, exactly. Like the group number one, in all the elements in the group one, they will have one electron in their valence shell. Right? So on this basis, we have groups arranged. So when we talk about the groups, the atomic radii increases down the group. Okay, the atomic radii will increase down the group. And why it will be increased? Because down the group shells will increase, number of shells will increase. Okay, I can write it. I can wait a minute. When we in the period shells are not increased. Okay, in the period you have just those same shells, just the nucleon
Outer
number is
electron shell.
increasing. But when we talk about the wait a minute, yeah, okay, yeah. Okay, yeah, I was talking about the shells in the
The
periods.
number of shells.
Yeah, in the periods, the number of shells are same. When we talk about the periods, across the period the shell numbers are same. That is why the electrons will arrange themselves in the same shells, okay, in across the period. But when we talk about this in the groups you have more shells, okay. Shell number increases, atomic radius increases down the group because of increased number of shells. Clear?
Yeah.
Okay. What will happen when shells will increase? How the increase in shell will increase the atomic radii? Can you suggest any idea?
What?
I am saying how this is related to the increase in atomic radii. How the increase in number of shells will increase the atomic radii. How this statement is linked. Two things in this statement.
If when the number of cells increases,
What will happen?
the atomic radius will also increase.
Yes. You see, when the shells are increased, so you have now more shells for electrons, and electrons will arrange them in those shells, different at different positions, right? So those electrons will repel each other now. Previously, across the period, when we were discussing about the periodic trend in the period, at that time I was saying you that there is just those particular specific shells, okay, and in those shells electrons are arranged, so they cannot repel each other in that case. But when you have more shells, they can repel each other because they are at different arrangement and at different positions. They are present at different positions, and uh, the inner shell, the electrons in the inner shell will obviously repel the electrons of the outermost shell, and this is how the atomic radii will increase. Are you getting my point?
Yeah.
That I am saying the are now distributed in more shells. So the inner shell electrons will repel the outer shell electrons. Within the same shell they cannot repel, okay, within the same shell, just like this, within the same shell they cannot repel because they are far apart from each other. We will discuss this later on, that what is the arrangement of the electrons within the same shell. So just remember at this point that in that particular same shell they cannot repel each other. They can only repel when there are different shells, okay, when there are different shells. Just like wait a minute, I have, yeah, like this. Like if I have, for example, I have electron over here, they will be present like this, electron over here. You will discuss this later on, that they will be always present in the bonded form. Over here the electron is over here, so they can repel each other, okay, they can repel each other. But when we talk about just one shell, in this the electrons are at maximum distance from each other, so these two electrons within the same shell they cannot repel each other. Are you getting my point? I'm
We can't
saying
repel each other.
within the same shell, this is the same shell. In this shell these are two electrons, can they repel each other now?
Yeah.
How can they repel? They are far apart from each other.
Hmm.
They are in the same shell, and in the same shell they are arranged at maximum distance from each other. Now can they repel each other?
No.
Yes, this is what I am saying. Within the same shell they cannot repel each other. So when we talk about the periods, I was telling you, across the period, even though the positive charge is increased, the electrons will be in the same shell and they cannot repel each other in the same shell. Okay. But when we talk about the groups, uh, down the group, when you have more shells, so in those more shells the electrons are arranged at different shells, in different shells, right, like this, at different positions. Now they can repel each other. The inner shell electron can repel the outer shell electron, and the outer shell electron can repel inner shell electron. This is the case. Are you getting this?
Okay.
And this will increase the
Yeah.
radii. Still confused?
No, I get it.
Okay. So down the group, why the atomic radii is increased? This you will discuss in the shielding effect part. That there will be shielding of the electrons in between. There is shielding of the electrons, and till at this stage, I am just simply explaining you that the inner shell electrons. Now you have more shells, and the electrons are distributed in those different shells. Now they have more opportunity to repel each other. The inner shell electrons will repel the outermost shell electrons, and this is how they will get far apart from the positive nucleus. Okay, and now the nucleus will have less effect on the outermost shell electrons. Clear?
Yeah.
Now the nuclei pull will be decreased. Over here, the nuclear pull was more. Across the period, the nuclear pull was more. Okay, more nuclear pull. What is meant by nuclear pull? That nucleus will attract the electrons toward itself. In down the group, there will be less nuclear pull. Okay,
Okay.
why?
They have less nuclear pull because the
No,
electrons have their photon.
because now you have more shells, electrons are far apart from the nucleus. Okay, the you will say simply nucleus have less effect now on the outermost shell down the group, because the atomic radii is increased. That is why less nuclear pull, because atomic radii is increased, which will, due to which, when atomic radii will increase, what will happen? There will be less effect of nucleus on outermost shell electrons. I am saying that with the increase in shells, the atomic radii is increased, and when the atomic radii is increased, the outermost shell is far apart from the nucleus. When the outermost shell is far apart from the nucleus, now nucleus has less effect on the outermost shell. Okay, the nuclear pull is less now.
Yeah.
That is why we say that down the group atomic radii increases. Clear?
Yeah.
Okay. Now we have an example over here. Firstly, we have seen this. If you see, this is the group one. Down the group, you see what is happening. The size is increasing. The atomic size is increasing. Why it is increasing? Because shells are increasing. Down the group, shells are increasing. And over here, if you see, across the period from left to right, the shells are same. The shell, you see this, if we talk about this, just this, so these all have same shell. These all have same shell: lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine and neon. They all have same shell. But what is happening over here is the number of proton is increasing. Across the period, number of proton is increasing, right? And number of proton is increasing, so there is more nuclear pull now. And when there is more nuclear pull, it can attract the outermost electron with more force towards itself. The nucleus can attract outermost electrons towards itself with more force. Thus, the atomic size decreases across the period. Clear?
Yeah.
Okay. And when we talk about in the groups, what happens when you go from down the group? The shells increases, the number of shell increases, and when the shell increases, the electrons are arranged in different shells, and they can repel each other. The inner electrons can repel the outermost shell electrons, and this is how the outermost shell electrons go far away from the nucleus, and nuclear pull is much less when you go down the group. And this is how the atomic size increases down the group. Clear?
Okay. Yeah.
Okay. Now we will talk about the, yeah, this is one example. This is one example of the period number 3 with values. What is the period number 3? You have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. Argon value is not written because data is not given in your book. For this sodium, if you see, what is the atomic radii? That is 0.157 nanometer, then 0.136, then 0.125. What is the trend you are observing? What is the trend over here
The
across the period?
radius is
This is period number 3. Whenever they will talk about the period, you must see that you must have this thing in your mind. In period, you will go from left to right, okay? From left side
yeah.
of the periodic table towards the right side of the periodic table. Clear?
Yeah.
And this is not just the meter, this is 0.157 nanometer, okay? Nano means 10 to the power minus 9. What do you observe from this data? What is your general observation?
I will go up from the period.
Sorry?
The atomic radius. The
Mm-hmm.
atomic radius decreases.
Yeah, atomic radius is decreasing, okay? And this is graphically represented over here. You see, this is the atomic radii range. This is for sodium, then magnesium, aluminum, silicon, and for different elements they have mentioned. For argon, it is not mentioned, so you will not plot it. Okay. Now we will talk about the ionic radius. Ionic radius is quite easy as compared to the atomic radii. Okay. The Yes, ionic radii. When you talk about the ionic radii, what is ionic radii? Simply, what can be the ionic radii? Radius.
Ionic radius.
Mm-hmm.
I don't.
It is the radius of the ion. Simple. It.
Radius of the ion.
It is the radius of an ion. And how an ion is formed? We have discussed it.
By the gain or loss of electron.
Gain or loss of electron from the atom. Okay. So you have two types of ions. What are those?
Cations and anions.
Cations as well as anions. Can you tell me the general observation about what can be the ionic radius of cations and anions? Which one have more ionic radii?
The anions.
The you see, the ionic radii of anions is more. Okay, it increases with the increase in with negative charge. Okay, the more the negative charge, the more will be the ionic radii of the anion, and the cation, it will decrease with the increase in positive charge. Okay, the more the positive charge, the lesser will be the radius. Are you clear with this statement?
Yeah.
Okay. Now when we talk about the negative ions, we say that the how negative ions are formed by accepting the extra electrons, right? The You have atom, that atom accept extra electrons, some extra electrons, and those electrons are added up to the to its shells. What will happen? There will be, when you will add more electron, there will be more repulsion between the electrons present in the different shells, isn't it?
Yeah.
So what will happen now? The nuclear pull will be less, right? The
Yeah.
nuclear attraction will be less, and this is how ionic radii will be more. So what we say, generally we say that uh, with the increase in electron number, like when the atoms accept the electrons, the at that time you see the nuclear charge is same. If we talk about this anion, when anions accept extra electrons, when atom, you will say atom because we are talking about the atoms, when atoms accept extra electrons, the anions will form, and they will have same nuclear charge. Okay, nuclear charge will remain same. So what will happen? Now if you see electrons are increasing, nuclear charge is same, so ultimately there will be less nuclear pull of the on the outermost electrons. For example, if we talk about the chloride ion, you have a chloride ion like this, and this was 17 and 35.5. This was neutral. In neutral case it was like this, right? And now it has accepted an electron, and it became an ion. Okay, now what is the proton number of this? A is 35.5, Z is 17, right?
17.
Number of electrons, how many electrons are there?
There is 18.
Yes. And how many neutrons are there? Okay, we do not need to know about the neutrons because they don't have any charge. At this stage, if you see the proton number and the electron number, the electrons are more, right? This is what I am saying. When you add,
Yeah.
when there is extra electrons, so at that time your anions, there will be extra electron, but your charge will remain same. Your proton number will remain same. That will be 17. So if you have 17 proton, and now if you compare what is more, electrons are more, and when electrons are more, what will happen? There will be more repulsion. These electrons will arrange themselves in different shells. Like the extra electron will be different in the outermost shell, and the outermost electrons will go further away from the nucleus, and there will be weaker pull, where there will be weaker nuclear pull on the outermost electrons. Clear? So when you have
Yeah.
more electrons, you will say the outermost electron move further away,